Hello everyone. So in the last session we have discussed about the HCU paper, which is the assessment paper. So and I have discussed I think 16 questions. So here I will briefly once again with the other questions as sound clarity was not there in the earlier session. Now I think it is somewhat better. So the first question is about the acidity. So as the acidity is a property of the electronegativity or conductivity effect based property. So here it is discussed that so given vitriol, so if more vitriol are there, more acidity will be there. That will be the right. So we can also use DNP rule, distance number and prior power. Okay. So you need to take high priority for the distance. So less the distance, more effect will be there for the inductive effect. Okay. So next question. So length of the bond. Okay. So bond length is measured using MOT. So if it is multiple bonds, or the bond strength is more, length is less. Okay. Bond length is less, but more bond strength. Okay. So or more bond order. Okay. So if it is having 14 electrons, it's going to have more bond order, that is 3. Okay. 14, all the 14 electron systems going to have triple bond. Okay. So because of the arrangement of the bonding and anti-bonding molecular orbitals. So if it is one electron increase or one electron decrease, it's going to be bond order 2.5. If it is one more electron increase or it decreases, it's going to be 2. Okay, bond order will be 2. So theoretically 2.5 will be existing, but generally it won't occur in the organic chemistry. Okay. So whatever they are having electrons away from the 14 electron spaces, that will be more bond length having molecule or less bond strength. So that is what this N1 minus 16. Okay, 16 electron. Yes. So in turmeric molecule, it is present in curcumin, okay, which is the pigment of yellow color, and it is a alkaline. So next, which reduction? It is it will give trans product. Okay. So from alkane it will give trans product, that is E product, and that is what this. Next. So it is probability based question. Okay. So out of 10 candidates, if there is only 4 seats available. Okay. So and it's going to vote for one or more than one times. Okay. So then what could be the probability of getting the candidates voted? Okay. So it is a probability of sum of the total possible instances. Okay. So it is 10C plus 1, 10C, 10C2, 10C3, 10C4. What is meant by 10C1 means? So it is 10 into 9 factorial by 1 factorial into 9 factorial. So 9 factorial will cancel. So 10 by 1 it is 10. Okay, the same will repeat. So if it is C2, you need to take 10 into 9 to like that. Okay. So next. So this is based on ozonolysis. On ozonolysis, this is reductive ozonolysis. It's going to break up into the carbonyl compounds. So you need to find 2 carbonyl compounds. So this is benzene attached to this going to be the aldehyde part. So it is 2-phenyl acetaldehyde, and this will be the acetaldehyde. Okay, and that will be the products. Next. So base pairing. So it will be the pairing will be with purines and pyrimidines combination. One purine is going to attach with another pyrimidine. So adenine will attach with the thymine, and guanidine will attach with cytosine in DNA, okay, and adenine will attach with uracil in RNA, but guanine and thymine is not the combination. Okay. Next, non-zero dipole moment having molecules. All the lone pair having molecules will be non-zero dipole moment. Okay. So you can see the lone pairs. So in xenon and phosphorus, phosphorus it is not there, but it is trigonal bipyramid, which itself is a not symmetrical shape. So it's going to have dipole. So in SFR also you have lone pair. So tetrahedral is the perfect symmetrical orientation. If it is having four similar atoms, so it's going to be zero dipole moment. So this is from the analytical chemistry, zinc uranyl estate. So zinc uranyl estate is used for the sodium ions estimation, and Nessler's reagent is used for the ammonium ion concentration. Okay. Next, this is for from the acids and bases. So pKa values. Okay. So here it is given that pKa is 3.2 and approximate degree of dissociation, which is alpha. We need to identify. Okay. And concentration of the solution is given. Okay. So if you take this step, it's going to present in the 0.35 mole and it's going to dissociate H plus and F minus. Initially, this ions concentration will be 0, but at the equilibrium, whatever the extent of the dissociation, so that will be its breakage factor, and the amount of ions will be resulted in that amount whatever the extent of the dissociation is there. Means if it is having 60% dissociation, 60% of the ions are going to form. So each ion, each ion is going to have 0.35 into 60% of that. That is what alpha. Okay. So this is what the dissociation means. So each ion will be going to be present in the 0.35 alpha, 0.35 alpha at equilibrium. So Ka is the acid dissociation constant, which will be the concentration of the products by the concentration of the starting materials. Okay, at equilibrium. So 0.35 square and alpha square by 0.35 to 1 minus alpha. Okay, this results into 0.35 alpha square into 1 minus alpha. Okay. And next, conversion of Ka into the pKa. So minus log of Ka is equal to the pKa. So if I add minus log for the left side, we need to add for the right side. So by adding and substituting the values and simplifying them, we are going to get 0.03, okay, which is the alpha. Okay, so here he didn't ask the degree of dissociation. It is we going to mention it is asked in the percentage. Okay, so percentage means 0.013 into 100. So it is 1.3 approximately. The given answer is 1.3. That is what the correct answer. Okay. Next. So next, to enzyme catalyzed reaction. So basically it is concept oriented. So enzymes will catalyze enhance the reaction based on the decreasing in the energy of the intermediate or activated complex. Okay. So this is what the dotted line is indicating the enzyme catalyte, and straight line, thick line indicating the non-catalyzed. So it will not effect on the equilibrium of the reactant and neither effect on the equilibrium of the product, but it will affect on the equilibrium of the intermediate or activated complexes. This is from the activated complex theory also and catalyzed reaction also. Okay. Next. So intermediate in the Riemann-Tiemann reaction, of course, it is a carbon. You all know. Okay. Next, RS nomenclature. So This is a high priority group 1, okay, and 2 it is 3. So 1, 2, 3 it is in anti-clockwise, so it is S, and this is 1, this will be the 2, and this will be the 3. 1, 2, 3, this will be the clockwise, and this will be the R. So nomenclature will start from the high priority group. So 1, 2, 3. So and no need of numbering, so A is given A and B. So for A it is S, and for B it is R. Okay. Next. So this is given on the basis of modified Woodward reaction. Okay. So this is a wet reaction where water is present. This moisture silver state iodine combination reagent will give cis diode. If it is dry, it is going to give trans diode. Okay. So we discuss the mechanism as well. Okay. So in this initially this double bond is going to attack with the iodine. Okay. So iodine attack will result into the, as methyl is the above the plane, it must attack from the below. So iodine will attack from the below, and this will be the cation that will be attacked by the iodines in lone pair, so that it is called NGP. This NGP will result into the cyclic iodinium ion formation. Okay. Next, in the next step, silver state will attack. So it must attack from the above side. So now, as this is near a carbon, so it will not attack from this. It will attack from this and above the plane. Above the plane. Oh yes, you can allow that. And this is I. Okay. Now H2O will attack onto this, and this bond will go and attack, and this will eliminate. This reaction is one of the most repetitive reactions, so you must focus. Woodward reaction and Hoffman modification, okay, which are used for the diode system. So both the from the above side. See, H plus will eliminate, and if this, let's say this hydrogen. Now H2O will be taken, and this will become OH, and this will also become OH on hydrolysis. That is OH. Okay. Next. So here, which reaction for oxidation and reduction? So in Cannizzaro, self-oxidation, self-reduction will be going to happen. This we haven't discussed. Next, in non-aqueous solvents, BRF3 and nature of SBF3. So generally, non-aqueous solvents means generally a solvent in most preferable is water. Okay. If any other solvents which are other than water, that are said to be non-aqueous solvents. So as like water, every compound will not act the same when it is present in water. Okay. So if you dissolve some sugar in water, it will dissociate or it will dissolve. Okay. If the same sugar, if you add into the petrol, it will not dissolve. Okay. That is what. There will be a difference with the solvent systems also. Okay. The same thing, if you use BRF3 as a solvent, and SBF5 is dissolved in that, so it's going to become SBF6 minus, okay, plus BRF2 plus. So wherever the F minus ion absorber, anion absorber is said to be base, okay, anion donor is said to be acid, okay. So it is a basic. SBFI is a basic. Next. So A is the attraction forces between the atoms, okay. So which is given by the van der Waals. So van der Waals constant A is intermolecular attractions of the gaseous atoms, okay. So if it is intermolecular attractions increases, so gas being liquid possibility is going to increase, okay. Next, if it is B is the volume of the gas, okay. So size of the molecule. If the size is small, it's going to liquefy easily and vaporize less easily. That's why. So more compressible should have lesser size, okay, so that they can accommodate in the lesser amount of area, okay. So that is what I was more compressible, lower A value, okay, higher lower B value, higher A value, okay. Next. So this is from the coordination chemistry, you know. So you all are able to do this 18 electron rule, based on 18 electron rule. So as I have done, so it's going to give 2 and 4. If any other options you got, you let me know. We will discuss on this. Okay. Next, penicillin. So penicillin is the antibiotic. Okay. So it is going to have beta lactam. What is meant by lactam? Cyclic amides are said to be lactams. Okay. So if cyclic amide is derived, this is carboxylic acid. Next to carboxylic acid, this carbon is said to be alpha. If amine is present on the alpha carbon and this H and O is left, and it's going to form a amine. This is called alpha lactam. Okay. If it is beta on beta carbon, so this is a carboxylic acid and this is alpha, this is beta. So on beta carbon amine is there and lactam is formed, that is said to be beta lactam. So all the penicillin groups. So this is what a core of the penicillins group. Okay. So many penicillins are there. So in that family, so all are most probably antibiotic. They can be used for other toxic effects also. Okay. So penicillin family will contain beta lactam rings. Okay. Next. So here we ask for the superoxide, peroxide, and dioxide. So this is what O2 minus is a superoxide, and this is what. This is what superoxide, okay, and this is what peroxide, and this is what oxygen, okay. So dioxygen. Oxygen is the correct. Next, this number is missed, but I want to let you know. Okay. So surface coverage. This is from the surface chemistry. Okay, surface chemistry. So in this, the fraction that is covered on the surface. So this is what the fraction, the area of cover in dissociative absorption, where molecules are dissociated into two parts. Okay. So it's going to dissociate. Okay. If it is dissociating into two parts, the actual formula will be fraction of the occupied area will be Kb power n power 1 plus Kp power n. Okay. So here K is the absorption constant, P is the pressure. Okay. As the pressure increases, area of the absorption increases. Okay. So N is the number of atoms that going to dissociate into. Okay, so it is dissociating into two parts. So it is 1 by n. This is 1 by n. So it is 1 by 2, 1 by 2. So this will be the correct answer. Okay. Next. So these are very important to know the combinations and their names. So all are minerals. Okay, so HJS is the mercury alloy. Okay, sorry, mercury ore. So which is used for the cinema is going to used as a precursor for the extraction of the mercury. Okay, MnO2 is called as peroxide, and CuFeS2. Okay, chalcopyrite. It is called chalcopyrite. Next, iron and titanium oxide. It is called as limonite. Okay, tin oxide is called as a cassiterite. Okay, these all are ores which is used for the extraction of the metals. Okay, direct question may come based on these names. Next, so here it is from the thermodynamics. So about the free energy. Okay, so for it is electrochemistry and thermodynamics combination. Okay, so for a cell reaction, so this is what the cell reaction, oxidation and reduction, both the parts it is given, and the E0 value we need to estimate. Okay, so if you calculate the estimate, then you can going to calculate the free energy. So to calculate the estimate free E0 cell, okay, potential of the cell, you must sum. So the sum will be left. This is what more lesser value will be the anode, and more higher potential value will be cathode. So it is right cathode minus left anode. So cathode is 0.039 and minus minus anode. Okay, so which will be going to give plus 1.10. So delta G is minus enough E0 cell. So it is F is the Faraday 96,500. N is the 2 electron exchange. That is what I learned. So minus 2 into 96,500 into E0 cell 1.10. Okay. So we'll give 21,000. Sorry. 2,10,370. Okay, in joules. Okay, so if I convert it to kilojoules, it is 10 to into 10 to the power minus 3 or by 1000. So it's going to give 210 kilojoules. Okay, which is minus. So this is not option. This is option D is the correct answer. There was a mistake while submitting. Okay, next. So this is what the reaction based on the nucleophilic substitution reaction of engineering. So with the presence of nitro groups, so nucleophilic substitution will increases with the withdrawing groups. Okay. So with the sodium hydride, this OH and SH will be activated. So it's going to act as a nucleophile, will substitute on the benzene. So as the nitro group in nucleophilic substitution reaction, especially, so be careful, in nucleophilic substitution reaction it is ortho-para. If it is electrophilic substitution reaction, it is meta-directing. If it is nucleophilic substitution reaction, it is ortho-para directing. So its ortho group will be replaced. That's why option A will be the correct answer. Okay. So in this nucleophilic substitution reaction, benzene is the intermediate. This is also one elimination addition reaction. Next. So this is from thermodynamics, where entropy is change is asked. Okay. So for 1 mole perfect gas from pressure, initial pressure 7.6 to 2.9. So it is given in our atmosphere and asked for in the calories. So delta S equal to NR ln P1 by P2. Okay. So you must know all the formulas. If you are facing difficulty with all the formulas, you must note down the formulas. Okay. So if you need any formula, if you just open the notebook, you are able to see what could be the approximate or best formula is going to be set. Okay. So for this condition, it is delta S equal to nr ln P1 by P2 because it is given in the pressure condition. If it is not, it is nr ln V2 by V1 if it is given in the initial and final value condition. Okay. So N is the 1 mole. Okay. So 1 into here R is the as he asked for the calories, it is 2 calories. Okay. And I directly converted log into log, which is 2.603 log 7.65 2.9. If you just calculate and make it, so the answer will come 1.907. Okay. So calculation part must be done by yourself because you must able to do the calculation. Until unless if you are just able to get the formula and could not able to calculate till the final answer, it won't be any useful. Okay. So you are going to attempt only 50% of the physical question. If you are able to do complete calculations, simplifications, then you are going to do all the questions in the physical chemistry. Okay. Next. So it is from the atomic structure. First four orbit of the hydrogen is x. Okay. It is speed of first orbit. Okay. So asked for the speed of the helium. Okay. So velocity is proportional to the atomic number squared by the orbit number square. Okay. Square of the atomic number and square of the orbit. So if it is hydrogen, atomic number will become and it is given first orbit. Okay. So N1 will be the 1 and Z1 will be the 1. Okay. And N2 will be the N2 second orbit, it will be the 2 and Z2 will be the helium. It is atomic number. So earlier x will be 1 square by 1 square. Now x will be 2 square by 2 square. So it will again going to be x. Okay. Must. There is no change. Okay. So correct answer will be B. So this is what the questions. So tomorrow onwards we are going to start by the Zoom. So install Zoom everyone. If any doubts, you can ask or you can post in the last also. Okay. Thank you.